Welcome back, ladies and gentlemen. So today we're going to be taking a look at ratios and proportions. Okay. And yes, we're going to be dealing with a lot of fractions for this particular one. And we're going to talk about how we can compare different things. You probably use ratios a fair amount in your everyday life, as we'll kind of take a look at as we go through this. So to start off with, if A and B are two quantities that are measured in the same units, this is very important, okay, because we need to make sure that we are in the same units. Then the ratio of A to B is written as A divided by B, or A colon B. So we say that, A to B ratio, okay? So for number one here, it says rewrite the fraction so that the numerator and denominator have the same units, then simplify. So for part A, we notice we have 10 feet over 16 feet, all right? So I have 10 feet over 16 foot. What you want to try and do is you want to try to reduce these down. What number can go into 10 and also 16? So we can divide the top by 2 and the bottom by 2, and we're going to get 5 over 8. So 5 foot to 8 foot, okay? And how we want to write our final answer out is we want to say 5 foot to 8 foot ratio. Okay? So you have 5 foot to 8 foot. You can write them as both. They are actually the same exact thing. I'll specify, when you need to do one over the other. Okay? So for our next one, what we can take a look at is 30 foot to 20 inches. How many inches are in a foot? Well, we know that there are 12 inches in a foot. So what I have to first do is convert the 30 feet to inches. So I'm going to multiply the top one by 12, okay? Because every 1 foot has 30 inches. So that ends up giving me, which I can take a calculator here, 30 times 12, 360 inches over 20 inches. Now, this actually takes me into, I could take my calculator and do 36 divided by 20. In this case, it works out that I have an 18 inch to 1 inch ratio. Now, normally you don't put the 1 inch in the bottom, but when we're writing about proportions, or rather ratios, we want to make sure that we include it, especially when we write out this statement. It's an 18 inch to 1 inch ratio. Okay? We always want to include units as well. Okay. Part C, what does 2mi stand for? That's 2 miles, okay, over 3,000 feet. Well, how can I figure out how many miles there are, or how many feet are in a mile if you can Google that, okay? You're going to find out there are 5,280 foot in 1 mile, okay? So I have 2 of them. So, we end up getting 10,560 feet over 3,000 feet. Now, I know in the first problem I showed you guys, hey, we can divide top and bottom by 2. Here, I'm not so sure what I can divide by. I do notice that both of them have a 0 on the end, so I could cross them off, meaning dividing by 10. But let's speed up the process a little bit. 10,560 divided by 3,000. Okay, oh no, 3.52, that's so terrible, I want a fraction. Well, here's my math button on my graphing calculator. Okay, and I can hit enter, enter, and wouldn't you know it, it reduces it down to 88 feet over 25 foot. Feet, yeah. Okay, which I can then write as 88 feet to 25 feet ratio. Okay, feet, foot, you get the idea. Okay, wonderful. Lastly, for this part, we have 6 yards over 10 feet. If I want to convert yards to feet, I have to multiply it by 3, okay? If you guys are having difficulty with these ratios, you can always Google them to find them out, or, you can use a buddy, a friend, so on. So I have 18 foot over 10 foot, okay? I can reduce top and bottom by 2, so I get a 9 foot to 5 foot ratio. If I write that out, 9 foot, 5 foot, we're all set. Okay, very good. So ratios, simplifying things down, make sure you have the same units. Make sure you have the same units. Okay, it's very important. Okay, now, a ratio is a direct comparison. Okay, so like miles, or this over this, so on and so forth. These are actually really helpful in real life, like if we're looking at a scaled map. Everyone ever used Google Maps before? Google Maps is just a ratio, okay? Because if you're looking at your phone, right? If I'm looking at my phone right here, and I'm trying to figure out where I'm going to, it's not going to be 1-to-1. Because if it was 1-to-1, then the street that you're on would be as big as the street that you're on your phone, which is impossible. Okay? A proportion is a little bit different. An equation that equates two ratios. So A over B equals C over D. Just some little vocab for you here. Your extremes are your A and D. Your means are your B and C. I need you guys to know a proportion is basically an equation. So it's ratios with an equal sign. Okay? Now, this is one of the most important things that you're going to learn here, especially this entire section. Something called cross product. Okay? Cross multiplication. The product of the extremes, okay, equals the product of the means. So what I'm doing here is I'm doing A times D equals B times C. Okay? Just multiplying. You've done this before. We can only do this when there's a proportion. Okay? And then there's the reciprocal property. If two ratios are equal, then their reciprocals are also equal. If I have A over B equals C over D, I can flip everything, and I'll get B over A equals D over C. Okay, so you can reciprocate everything. Reciprocals, reciprocate means to flip. All right, very good. Okay, on the back, we have here, use a number line to find the ratio of the distances. Okay, it's pretty simple. A to B, you're finding the distance. Now, I know this is going to sound really, really kind of elementary, if you will, but when I'm counting from A to B, I'm going from here, I go 1, 2. So the distance here is 2. My distance from C to D, 1, 2, 3. Your distance must always be positive. Okay, so my ratio is a 2 to 3 ratio. Very good. Now, B to F, you're going to notice that this is a long way, and I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But Mr. Howard, isn't there an easier way to do that? Sure. F is 13, B is 2. What is 13 minus 2? 11. Okay. Same thing here from A to D. I can do 9 minus 0. 9. 11 to 9 ratio. Okay. Cool. Lastly, CD, from here to here, okay, that's a 3. AB is a 2, okay, and then I have a 3 to 2 ratio. Guys, do you think these two are the same? Are they the same ratio? I'm hoping that you guys can see they are clearly not. All right, I know they look very similar, same numbers, but they are definitely different. Okay, here comes my favorite. I love this part. So solve the proportions. We are going to cross multiply because I have two fractions equaling each other. So, if I always start top left times bottom right, 20x equals bottom left times top right. 5 times 8 is 40. Okay, just to show you that work over here. How do I solve that? Well, hopefully by now you guys are feeling pretty confident. We just divide by 2. X equals, we divide by 20. X equals 2. My bad. I'm trying to get too ahead of myself. Ta-da. You're done. Okay. Very good. Taking a look at part B. It's a lot of the same, but again, you can't get too good at this. Y times 15 is 15y. 6 times 8 is 48. Okay. So if I divide by 15, this isn't going to go in nicely. So here's where, okay, let's take our calculator out. I'm doing 48 divided by 15. Okay, I want you guys to get in the habit of putting your answers as fractions. So math, enter, enter, 16 over 5. Okay, very good. Part C. Okay, here's your first curveball. If I were to, I'm going to first write 8 times x plus 6. You must put parentheses around it. That's the whole catch. Okay, here's your big reveal. Equals 12 times x is 12x. All right. So what I'm looking to do here is to distribute this 8 in. 8x plus 48 equals 12x. I want to get all the x's on one side. Well, I'm going to subtract 8x over. So 48 equals 4x. Divide by 4. X equals 12. Okay, so very good. If you guys are interested, okay, so for example, part C, if I do 8 divided by 12 on the left, I get 0.6 repeating. On the right, if I do 12 divided by parentheses, 12 plus 6, I get the same thing. Hey, what do you know? They're equal. I know I'm right. So it's a good way to check. Okay. Lastly, okay, again, much the same. 5 times y minus 3 equals 3, parentheses 2y minus 7. Okay, I'm going to distribute 5y minus 15 equals 6y minus 21. Cool. I'm a super positive guy, just like you guys all should be too. So I'm going to try to keep the y's positive. I'm going to subtract 5y from both sides. Negative 15 equals y minus 21. I'm going to add 21 over. Please be careful with your signs. Uh-oh, what's 21 minus 15? 6. So y equals 6. Okay. Definitely a little bit more involved there, a few more steps, but you can see we're gradually growing to where we want to be. Okay? Awesome. So, for our last and final one here, Mr. Jones and Me, good song, look it up, Counting Crows, has taken a survey of college students and found that 70 out of 76 students are liberal arts majors. If a college has a grand total of 7,613 students, what is the best estimate of number of students who are liberal art majors? Okay. Well, we're going to make a ratio, we're going to make a proportion here. 70 out of 76 students are liberal art majors. So 70 out of 76. Okay? So that's your liberal arts. And that's your total. Okay? I want to make that equal to, they're telling me a college has 7,613 students. How many of them are liberal arts majors? Well, I'm trying to match it up. I don't know how many of them are liberal arts majors. But that's going to go on top. On the bottom, I'm going to put 7,613. Now, what do you know? Now I can just cross multiply. I'm going to put 76x. I just like putting the x on the left-hand side. It's the math teacher in me. And then I'm going to do 70 times 7,613. Ooh, that's a big number. Okay, so 532,910 divided by 76. Okay, so I have 7,011.97. Now, because this says what's the best estimate, we're okay here. So I can roughly estimate that estimate there's going to be 7,012 liberal arts majors at this college. Okay. Normally, when you're talking about people, if they were asking for an exact thing, you wouldn't want to round up because you can't have 0.97 of a person, but when we're talking about estimating, it's okay. All right. So, cross multiplication, very important here. Okay. Make sure you're dealing with the same units, and it's always good work. Keep up the good work, and good luck. We're all counting.